The universe is estimated to be about 14 billion years old, but before that, it was a mysterious puzzle no one could solve. However, the James Webb Telescope has been taking us on an extraordinary and awe-inspiring expedition to explore the very edge of what we know about our universe. And well, it's getting crazier as the James Webb Telescope has just announced what's at the end of the observable universe. No other than renowned astrophysicist Neil deGrasse Tyson has recently shed light on this incredible announcement. What mind-boggling and shocking things lie at the end of our universe? Join us as we bring you the astonishing revelations from the James Webb Telescope with the help of Neil deGrasse Tyson's expert analysis. Scientists, philosophers, and curious minds have been always fascinated by the sheer size of the universe for centuries. While we don't know the size of the entire universe, we can measure the observable part, which is about 93 billion light-years in diameter. To put that in perspective, we should know that a light-year is roughly 5.88 trillion miles or 9.46 trillion kilometers. This means the observable universe is a whopping 546.84 billion trillion miles or 878.58 billion trillion kilometers wide. But why is our universe so vast? To understand the vastness of space, let's return all the way to the Big Bang theory that suggested the universe burst into existence about 13.8 billion years ago. Since then, it's been expanding crazily fast, fueled by things like mysterious dark energy. As it expanded, matter clumped together, forming stars, galaxies, and eventually, planets like Earth. However, with all this growth, the universe is still mostly empty. Our solar system, if shrunk to the size of a quarter, would leave the nearest star 2 soccer fields away. That's how tiny we all are. Now, let's talk about the observable universe versus the universe as a whole. We know the universe encompasses everything, from matter and energy to space and time, regardless of whether we are aware of it or not. But the observable universe is what we can actually see or detect from Earth or our space-based gadgets. It's like a bubble around us, determined by how far light has traveled since the universe began. And that's about 93 billion light-years wide. So, what's the logic behind the part of the universe we can see? How do we understand what's in or outside our observable universe? Well, by now we know that the observable universe is just a tiny fraction of the universe, and it's the part we can explore and study. The true size of the whole universe, on the other hand, remains a mystery. And there are plenty of reasons we can't see the entire vastness of space. For starters, the universe might be infinite, or there could be limitations to what we can observe due to cosmic phenomena, or the nature of light itself. Neil deGrasse Tyson highlighted in an article once that there's a limit to how far we can see in space. If something travels at the speed of light, there's a specific distance from us where galaxies seem to be moving away so fast that the light they emit can never reach us. It's like a boundary where the speed of their movement away from us matches the speed of light. Put more simply, when a galaxy is at this distance or even farther, the light it emits loses all its energy before it reaches us. So, beyond this point, there's a sort of invisible wall in space that prevents us from seeing anything there. That's why some often refer to it as an edge. This also explains why when we gaze at distant objects in space, we're peering into the past. Light takes time to travel through space, and the farther an object is, the older the image we see. Also, the universe is expanding, causing things to move away from us faster and faster. This makes their light stretch out, turning it into redshift, which can make it tough to detect. Eventually, these far-off objects may scoot so far away that their light won't reach us anymore. What's at the edge of the universe has been a mystery for scientists and thinkers for ages. They've pondered on it and gotten various ideas, but there is no definitive answer yet. One theory even says the universe could be infinite, without an edge. It's based on the idea that the universe looks about the same in every direction, known as the cosmological principle. If this holds, it means the universe stretches on forever, with no boundary. To prove some of these theories as facts, the James Webb Space Telescope, also called the JSWT, was invented. This high-tech eye in the sky has made some mind-blowing discoveries, like identifying the earliest strands of what's called the cosmic web. It's a massive network of galaxies and threads spanning the universe. But that's just a bit of what the JSWT has revealed to us. This cosmic web tells us how matter spreads out and how galaxies evolve. Its creation began with tiny fluctuations in matter density after the Big Bang. These grew over time due to gravity, creating regions of different densities. The denser areas collapsed into galaxies and clusters, while the less dense regions expanded into voids. Filaments formed between these areas, channeling gas and matter toward clusters. How was the James Webb Telescope able to discover this? The JWST, with its powerful infrared vision, spotted some of the earliest cosmic Webb filaments. It has a huge 6.5-meter primary mirror made of 18 hexagonal segments crafted from beryllium coated in gold. That's 7 times larger than the Hubble Space Telescope's mirror. This enables it to gather more light and peer into the depths of the universe to spot even fainter objects. Talking about its infrared vision, the JWST can see in the infrared wavelength range of 0.6 to 28.5 microns. This ability allows it to bypass obstacles like dust and gas that obscure visible light. This way, it can gaze at the first galaxies that emerged after the Big Bang, witness the genesis of stars and planets across galaxies, and explore our cosmic neighborhood like never before. All of these combine to help the JSWT demystify the cosmic web of our universe. In a study led by Fij Wang from the University of Arizona, astronomers peered back 830 million years after the Big Bang and spotted a thread-like arrangement of 10 galaxies, secured by a bright quasar. As we progress, you'll understand what that means. These galaxies, though fainter and smaller, appear aligned along a diagonal line, hinting that they could evolve into a grand galaxy cluster, similar to the well-known Coma cluster in our nearby universe. This glimpse into the early cosmic web sheds light on how these structures formed and evolved, giving us a clearer picture of the universe's vast, interconnected nature. The James Webb Telescope continues to reveal these secrets about the early universe, and the world-renowned astrophysicist, Neil deGrasse Tyson, is now getting involved. Neil deGrasse Tyson's love for these mysteries runs deep. He has always been captivated by how science intertwines different fields and weaves them into a reasonable story, and his excitement is evident in his enthusiasm for the show Cosmos. This series brilliantly connects geology, chemistry, biology, and quantum physics, showing how they all play a part in understanding our cosmic existence. Surprisingly,